Alright, welcome back to this class, and here we want to integrate this particular function. So what you want to do is, there's nothing you can start with this. So you know that this is also the same thing as the integral of the ln of x over 2 times 1. N times 1, so I have not changed the question, so it's still the same thing, right? Now, because I have something like this, I can implement the knowledge of integration by parts. Integration by parts. And when we say integration by parts, we're talking about integral of u dv will now be uv, right, minus the integral of v du. This is what we want to make use of. So to do that, it means that in this case, my u now will be my n of x over 2, and my dv will now be my 1, which means that if I should get my v, I have to integrate it, and that will be v is equals to x. So far we can now work on our integral. So integral of ln of x over 2, which is times 1 also, can now be written as our uv. So my u here is my ln of x over 2, right? Then my v is x, so let me put the x at the back here. Do you get now? So minus the integral of my v, which is x, then du. So I want to differentiate the ln of x over 2, and we know that to differentiate the ln function, we have to differentiate the function over the function. So let's do that here as a rough work. If I have a ln of x over 2, to differentiate x over 2, that's 1 over 2. Okay, so 1 over 2, then over the question back, x over 2. So x cancels s, so I have 1 over x basically. So my dv, my du will now be 1 over x, right, dx. So you can see that x has cancelled out. It is out, so I'm left with 1 there. So the integral of the ln of x over 2 is x to the ln of x over 2 minus the integral of 1 dx. And of course, how do we integrate ln? How do you integrate 1? That's x, because we are with respect to x. So my final answer will be the ln of x over 2 minus what? X. Then we can also factorize, basically. We can have that x in bracket the ln of x over 2 minus 1, then what? Plus c. Thanks for watching.